So in this new video, we will discuss different fittings used. First, we start with the end caps. So end caps are used as a cover to the open end of the pipe, permanently or semi-permanently. It has a single opening that is welded or threaded into the external diameter of the pipette. It has a domed or flat shape on this closed end. Its function is to terminate the flow of the pipe in a pipeline. Application: sealing the end of a process pipe, and it can be used in hydro testing, static testing, closing of unused outlets of a manifold, etc. So that is the end cap. Now stub ends. Stub ends is a short piece of pipe that functions as one half of a flange connection. It has always a conjunction with a separate component called a lap joint flange, sometimes called a Van Stone flange. Design is that the sometimes look like a short pipe section with one end flared or flanged over the lap, and other end is prepared for butt welding to the main pipe. One end flared or flanged over the lap. So other end is prepared for butt welding to the main line. It is not a complete sealing component on its own. So what will happen? So it's a flexible way to create a flange joint. Which I can show you the photo. Like this. So this is the stub end, this is the butt joint, and this is the flange. So stub end means it is stubbed or flared. So what will happen? A flap is two-piece instrument that 1 minute. So this lap joint flange is a two-piece assembly, like I said, loose rotating flange ring with a stub end. This stub end is a short section of a pipe with a flared end to create the pipe connection. The stub end is butt welded to the pipe, while the flange itself is free to rotate around the pipe and the stub end. So it's a two-piece design. It consists of a loose joined flange and the stub end. Welding is the pipe is butted to explore flared end of the stub end. Flange ring itself is never welded. Why we are using it? We are using it to this flange can rotate freely around the stub end, so that when we are aligning the bolt holes with a mating flange, much easier during the installation or maintenance. The seal is created by a gasket compressed between the flared face of the stub end and the face of the mating ring, and not by the flange joint itself. So sealing is also done. So its main purpose is aligning the bolt of the flanges are easy, because this lap joint flange is loose. So codes are ASME B 16.5 and 16.9 and MSS SP 43 covers the dimension tolerance of butt weld stub ends, which is classified as pipe fittings. Now the summary: this end cap closes of the end of the pipe forms a flange connection with the stub end. Used alone, yes, but not requires a lap joint flange. Shape is solid, typically doomed or flat. Short end with a flat end. lap. So connection type is a welded or threaded onto the end cap is welded or threaded. It is welded in stub end is welded into the pipeline, then bolted into another flange. Fluid contacts the fluid entirely at the end. Only the internal surface and the flayed lap contact the fluid. So this is we just what is this lap joint flange and the stub end and the end cap. Okay. So we will discuss other fittings also. One is elbow, T, and reducer. We will discuss. Elbows are used to change the direction of fluid flow 45 degree to 90 degree, used to route pipelines around the obstacles. T's splits or combines flow from a main line into the branch line, creating a three-way connection. It is essential for creating multiple branch piping networks. Reducers connects pipes of different diameters to change flow, velocity, and pressure. Used in gravity-fed systems or industrial pipelines where different pipe sizes need to be joined efficiently. Then coupling and union, the two connect two pipes in a straight line. Union allows for easily disconnection for maintenance. Used in general pipe jointing like residential plumbing, etc. So we have this end caps. It seals the ends of the pipe for fitting opening to terminate the flow and prevent leakage. Used to close off the future extension points in fire suppression systems or steel operational ends in the oil and gas pipelines. Flange is connects to pipes to valves, pumps, and other equipment using bolts, providing a leak-proof and accessible joint. It is widely used in power generation facilities and large industrial systems where components may need to periodic assembly and disassembly. So, connects pipes to valves and pumps and other equipments. That is, we are using flange. Cross, it is called cross connections. Connects four pipes at a single point, allowing fluid flow in four directions. Used in complex piping networks. So multiple flow diversions are needed. So we use this cross. Then connection types are butt weld fittings joined by welding directly to the pipe ends. We have a seamless, strong, permanent leak-proof connection suitable for high pressure, high temperature, critical industrial applications like etc. Forged fittings, socket weld and threaded, threaded fittings. This goes through the forging process for enhanced strength. It can be used for smaller pipe diameters, while threaded fittings are typically used in low pressure applications where welding is not appropriate or easily disassembly is required. So now we will discuss what difference between Weldolet and Olet. Now we will discuss Weldolet and Olet. Now we will discuss difference between Weldolet and Olet. Olet is a general term, while Weldolet is a specific type of Olet. Olet is a trademark of Bony Forge, but it is widely used as a general term, just like our JCB. So, so it is integrally reinforced forged fitting used to make branch connections. Branch connection may be from a larger head or header to a smaller branch or outlet pipe. Olet offers an alternative to using a standard tees or creating pipe branch connection with a reinforcing pad or saddle. So we are providing reinforcing pad or saddle, just like this one. 1 minute. Olet is a generic term and Weldolet is a specific term or type of Olet. So Olet is a trademark of Boni Gork, but it's generally used as a generic term. So it is integrally reinforced for the fittings. and it is used to create a branch connection from a large run or header to a smaller branch or outlet pipe. It offers an alternative to using standard tees or creating a pipe branch connection with a reinforcing saddle. So, what is a reinforcing saddle? So here we can see that Olet is used as an alternative for standard tees or creating a pipe branch connection with a reinforcing pad or a saddle. Why? So it is an alternative to pipe branch connection with reinforcement paddle because so what is a reinforcement pad? It's a metal plate. It is welded to a nozzle or branch connection in a pipeline to compensate for the weakening of the material, that is to increase strength in the high stress area. This high stress area is created when an opening is made by cutting a hole in the for the connection. So cutting a hole removes the materials which will weaken, which significantly weakens the parent pipe. So this handle this high stress area Repad adds material and distributes stress more effectively. So the connection is strong to withstand the pressure and load with it will encounter. So it is essential for maintaining the structural integrity of the system. They are used to strengthen the fabricated branch connections, stub in or stub on, which are not inherently strong as standard fittings like the tees. So it is used in the branch connections where the smaller pipes connect to the larger head pipe, where the supports like a trunnions are welded to the pipe. So we must know what is trunnions. So a trunnion support in piping is a welded pipe branch. It reinforces and stabilizes a main pipe. It transfers its weight to a secondary support structure. So here trunnions, uh, stanchions and dummy legs. These supports are common in industrial pipeline because they are relatively easy to construct and effective in both the horizontal and vertical lines. Help to manage the heavy loads and reduce stress, especially at critical points like elbows. So we discussed the trunnions. So there are other important question. Why repads are uh, is repads necessary with Olets? So Olets does not require reinforcement pads. Why? Because they are self-reinforced fittings. It is designed to provide a sufficient structural integrity on their own. Olex is a trademark of Boni Forge. They are specially engineered and manufactured with a thicker contoured design. It compensates the material removed when a hole is cut in the main header pipe. So it maintains the overall strength of the connection. Stress distribution also is distributed effectively across a larger area of the header pipe, preventing the high stress concentration that would have been occur with a simple stub-in or stub-on connection. What is stub-in or stub-on connection? It's a straight line welded in the whole of the pipe. So it is an alternative to fabricated tees. Repads are typically used with the field fabricated branch connections. to compensate for this lost material. So OLS provides more reliable and pre-engineered alternative to this field-made reinforced joints. In summary, use of OLED is deliberate choice made to avoid uh, calculation, material, and labor involved. Okay. Here we will also discuss how a reinforcement pad is provided. So this is a reinforcement pad provided. There was a hole and a pipe is inserted. A stub in or T connection is inserted. So what is happening? There will be stress concentration and there is hole weakening in this one. So what will happen? We are going to provide this reinforced branched. Okay. So these are the requirements of a reinforcement pad. That is it should be same material as the run pipe. That is header pipe, and the width is half the diameter of the branch pipe. This is a branch pipe. It's half diameter. This width will be half diameter, and at least 50 mm width will be there. Thickness should be the same thickness of the run pipe. It should be same thickness of the run pipe with a 3 mm minimum and a maximum of 20 mm. So what we will do, we will cut the hole exactly as the internal diameter of the branch pipe. Then we will make a beveling of 30° for the welding this one, branch pipe into the parent pipe. Okay. Now branch is welded and tack weld on the run pipe. Then the branch can be completely welded and the NDT is done. Then reinforcement pad is a slide into this pipe, and again tack weld is done. Okay. Here we can see the testing of a reinforcement head. Here is a pressure gauge and the pressure is applied here. Okay.
Hold me close till I get up. Time.
So this weapon is provided. It is also called a telltale hole or vent hole. So why it is used? What is the usages? By threading the hole, a test cage can be threaded for an air or a soap test for check for leakage. That's the one thing. So it also serves as a vent during the welding for entrapped gas to escape and not becoming a jacketed vessel. Also, after completion of the pressure test, these sweep holes are sealed by welding itself. So this is about the reinforcement pad and the weep holes. Now we will discuss. Um, Go back to the this section called. Now we reached here. Okay. So coming back to OLEDs, they are designed to manage stress concentrations at the branch junction without requiring additional reinforcement pads. Versatility, it comes across various type of accommodate different connection methods like a welded, threaded or flanged and angled like a 90° or 45° application is widely used in high pressure or high temperature industries. Okay. So we will discuss some OLEDs which are special. Weldolet. It is a common type of Olet. It is primarily driven to create a 90° branch connection via butt welding to both run pipe and the branch pipe. Connection method is a beveled edges, making it for a butt weld fittings. Full penetration weld is used to join it to the branch pipe. Pressure rating, it is suitable for it is full welded design. It is suitable for high pressure and high temperature applications. Size range can wide range of branch sizes from small to large diameters. So summary of differences. So Olet is a family of branch connection fittings. Is a special type of Olet fitting, Weldolet. Connection to branch can be butt weld, socket weld, or threaded. And Weldolet is exclusively butt weld connection. And the type is varies B-weld, socket, threaded. It is B-weld for the Weldolet. Primary general branch connections within the piping system, high pressure, high temperature, butt welded connections. So other type of Olets are Socolet, Threadolet, and Lateralet. Threadolet is known for threaded connections, Lateralet for 45-degree connections. What is Socolet? We have a detailed PDF here. Now we will discuss what is the socket lock, socket. It is used. So now we will discuss what is socket. Sockets main difference with Weldolet and socket are welders use butt weld, socket use socket weld, and threadolet use a female threaded connection. They dictate uses with Weldolet for high pressure, socket for medium pressure, and threadolet for low pressure, small diameter pipes. So welded is butt welded, it is socket welded, it is a female threaded. Yeah, example NPT. Pressure type is high pressure, moderate pressure, and low pressure. Pipe size is no resistance used with the large pipes, smaller to medium size, and small pipes for threadlet. So that is the difference. Installation requires skilled welding. Requires welding, but similar than butt weld because it is like a fillet weld. And screwed in place, no welding required. Typical use heavy industries like piping and gas, instrumentation, small branches, socket, and low pressure instrumentation systems. So now we will discuss what is socket welded. Socket weld is a type of joint used to connect a pipe fittings by inserting a pipe into the recessed socket and applying a fillet weld around the pipe. It is a non-threaded connection, typically for a smaller pipes where high leakage joint is needed. So medium to the socket weld is shown here. Here, picture is not visible properly. So it is kind of say fillet belt. It is used in the medium pressure pipes. Okay, that's all. This scenario we will discuss also this rising about the rising main. What is a rising main actually? It is a pressurized pipe that carries water such as sewerage, wastewater from a low elevation to higher one using pumps. Pumping is essential. Pressure management there will be because pressurized require careful design to manage in the international forces. Blah blah blah. Common situations: wastewater and sewerage system. It is the primary use. Often needs to lift out from the low-lying areas to higher point where it can flow by gravity to a treatment plant, etc. Water supply in multi-story buildings. Rising means transport potable water from the drinking water from the ground level main supply to higher floors, etc. Fire protection, not as wet risers or dry risers in this context. Wet risers always allows water fighters to quickly deliver water to various floors during emergency. Dry risers are empty when until needed and charged by a fire engine pump, while the wet risers are permanently filled with water. So these are about the rising mains. Okay. So the next question is if the thickness of the CS pipes and CS fittings same and why? Although all system of the system all thickness wall thickness of the system is designed to match a nominal wall thickness corresponding to a CS pipe schedule. So standards like ASME 3610. Okay, but the fittings are on the standards ASME B16.9. So there will be but there will be slight difference in the actual minimum wall thickness and how manufacturer achieve that thickness for a specific reasons.
The entire PVC system is engineered to have consistent pressure rating. Therefore, if you buy a schedule 40 pipe, we are expect corresponding schedule 40 elbow or teeth to provide a similar level of structural integrity. But compatibility for ease of welding and proper fit up, outside diameters and the intended wall thickness must be compatible. But when they are forming the fittings, it is made up by bending a straight piece of pipe or plate. This forming process causes material stress and can lead to wall thinning on the outside arc of an elbow and the thickening of the inside arc of the elbow. This will so standards for the fittings often specify that the thinnest point of finished fitting must not fall below certain percentage, like 87.5% of the nominal pipe wall thickness. To compensate for the expected wall thinning during the forming process, manufacturers sometimes start with the thicker pipe, like one schedule up, so that the final product meets the minimum specified thickness at all points. The ends are then machined to match the specific wall thickness of the connecting pipe. Both the pipes and everything have manufacturing tolerance, and the ASME specification for seamless pipes generally permit 12.5 under tolerance on the specified wall thickness. So, the ASME specification for seamless pipes generally permit 12.5% under tolerance for specified wall thickness. Fittings are similar but see different tolerance requirements to meet a minimum burst strength required by the standards like MSS Manufacturers Society, Specification Society, SP 75. So, in conclusion, for practical purposes, we can consider the wall thickness of the general CS pipes and their matching schedules fittings to be same, as are designed to work together as a system with a uniform pressure rating. Minor variations in activities and manufacturing necessities managed by the industry standards to ensure minimum required strength. To ensure minimum required strength. Okay. Abarno. So question is the matching of inside or outside of the pipe and fittings. Our outer diameter should match actually. Outer diameter, outside surface of the pipe and fittings are aligned flush with each other. This is critical for appearance insulation, ensuring consistent outer dimensions throughout the pipeline. Inner diameter transition, because our tolerances, there may be slight mismatch in the inner directions. Standards like Manufacturers Society SP75 ASME 16.9 allows for slight internal misalignment, which can be smoothly transitioned using a taper boring or a grinding process if a mismatch is significant. If it is typically more than 1.5 mm, the internal surface must be smooth as possible to ensure proper fluid flow and minimum turbulence or erosion. So, our question was that whether WPHY 52, our carbon steel fittings, which P number, group number it has as per our requirements. So, it lies in the group number 1, sorry, P number 1 and group 2 materials. So, P number also we already seen it's carbon steel. So, what is the P number it has placed actually? P number is assigned to base materials with the similar welding characteristics. So, it P number 1, it is in the P number 1 carbon steels. They are specifically in the group 2 of P1 materials, which are high strength carbon steel with certain limitations on composition and heat treatment requirements. G number used for impact toughness requirements. So our code ASTM A860 itself mandates impact test. So it comes under group 2. Our paramaterial X52 has P number 1 and group number 1, which does not require a mandatory impact test assignments, but what happens our code our specification requires impact testing is required in the construction code. In such cases, similarly the compatibility. In such cases, what we have API 5L X52 have this one lower alloy using this the tough standard toughness is sufficient, group number 1. But our specification mandates impact test requirements. So we are doing the impact test of these things also. But ASTM 860 PHY 52, even the code itself mandates the impact test, so it falls under group 2. So APL 5X52 and group number 1 and 52 and WPHY 52 fittings P number 1 and group number 2 are compatible because they are both classified under the same P number 1 in the ASME system. Also, therefore, ASTM this WPHI 52 fittings are fully compatible with the API 5X52 and equivalence the fitting standard directly correspond to API 5L X52 pipe standard. Both materials share the same high yield strength requirements, minimum yield strength of 52,000 or 360 MPa. So they are intended for high pressure services. A number of API 562 also A1 carbon steel. It's for deposited as carbon content of less than 0.15% and specific level of manganese and silicon. F number is assigned to filler material. Usually, filler material as E7018 is used so it falls under F number 4. So welding a P1 group 1 material to a P1 group 2 material is a common practice in the industry. As long as welding procedure has been qualified for this combination, it is considered code compliant and safe. Materials with the same P number has sufficiently similar fundamental properties and weldability to be welded together using a standard qualified welding procedure specification. So that's all for this regarding the P number 1, group number 2, etc. So we have a question about the scheduled number of our pipe API 5L X52. So what we are saying, what it means, it is not strictly correspond to a single standard published by ASME ANCC schedule number, because these standards typically cover size up to NPS 48 inch and perhaps up to 60 inch, but our pipe is 63 inch, 1600 means 63 inch. So sizes of this these large pipe requires custom manufacturing. For this custom manufacturing, these pipes are generally specified by its nominal wall thickness or millimeters or inches rather than an arbitrary schedule number. Manufacturer lists pipe as a special diameter and thickness combination as per API 5L standard requirements for LSAW and SSAW construction. So engineering documentation of specific pipe, we would rather say it by the grade per OD and WT, like API 5L X52 1600 mm OD, 25 mm WT. So this schedule number is a convenient designation for a standardized series of thickness for a given nominal pipe size. For extremely large custom engineered pipeline like this, wall thickness is determined by specific engineering calculations based on the required design, pressure, temperature, and applicable construction codes. Like ASME B31.4 for liquid pipes and 31.8 for gas transmission. So same the case with our API 5LX52 1400 thickness 15 mm. It is a larger diameter, NPS 56 grade. NPS 56 is our typical range of standardized schedules in the documents like B36.10 is runs up to 24 NPS and up to 48 and 48 NPS. But our NPS is 56 inch. So custom engineering is made. Wall thickness is custom engineered precisely for specific operating pressure and service conditions using calculations from the relevant construction codes like ASME B31.8 and ASME 31.4. In that case, a designation by wall thickness is specified by specific wall thickness in millimeters rather than a generalized schedule number, generic schedule number. So, engineering specification of this dark diameter pipe, it will be preferred by its full dimensions. API 5L X52 1400 OD 15 mm WT. The special dimensions are chosen to meet the pressure rating needed for the project rather than adhering to a predefined schedule table. Okay, thank you for watching. Now we will start with the next video with our slides we forgot. Okay.